Hi, this video will introduce our paper, Fashionpedia, Ontology, Segmentation, and an Attributes Localization Dataset. Recent progress in computer vision has advanced machines' ability to recognize and understand our visual world. These applications are supported by different visual understanding tasks with the goal of naming, describing, or localizing objects within an image. Naming and localizing objects, which is formulated as an object detection task, is to identify and indicate the boundaries of an object in the forms of bounding boxes or segmentation masks. Attributes localization, on the other hand, focuses on describing objects, since an object also have many other properties in addition to its category. In this work, we propose a new task, instant segmentation with attributes localization, which unifies object detection and fine-grained attributes recognition. This task offers a structured representation of an image. Automatic recognition of a rich set of attributes for each segmented object instance complements the category-level object detection and therefore advances the degree of complexity of images and scenes, which is an important step towards real-world application. In this work, we focus on fashion domain as an example to illustrate this task. We introduce a new dataset called Fashionpedia. Visual analysis of clothing is a topic that has received increasing attention in recent years. Some of the existing datasets focus on categorizing types of garments, while the others focus on detection of the apparel categories. There are other datasets that also include fine-grained attributes. Fashionpedia lies in this section as well. Additionally, we took one step further and segment both garment types and garment details like sleeves, collars, and pockets. And we also offer localized attributes. This is how we distinguish Fashionpedia with other related fashion datasets. Structured representation of images often rely on structured vocabulary. With this in mind, we construct the Fashionpedia ontology, which is informed by product description from the web and built by fashion experts. We consider common items in apparel as main objects. For example, jacket, dress, or sunglasses in this example. Main apparel categories can also have sub-objects, which means the part of the garments, like collar, pockets, or sleeves. Main garment and garment parts can also have apparel attributes. Here's an example. The fabric of this jacket is denim, and the silhouette of the jacket is symmetrical. To connect everything together, there are three types of relationship in total presented in our ontology: part to whole, generic to specific, and object to attributes relationships. To the best of our knowledge, this is the only public available clothing dataset that takes a leap forward at its taxonomy quality direction. In terms of image diversity, Fashionpedia contains clothing images in daily life, street style, celebrity events, runway, and online shopping domains. The images are annotated both by crowd workers for segmentation masks and fashion experts for localized attributes. We have more than 300,000 masks in our training images. Our masks also have the most complex boundaries comparing to 4 other common segmentation datasets. Fashionpedia also have the most diverse number of categories within one image among three fashion datasets, while comparable to Coco, since we provide a comprehensive ontology for the annotation. Our standardized taxonomy contains 46 apparel categories and 294 fine-grained attributes. To better facilitate research on Fashionpedia, we designed a strong baseline model named Attribute Mask RCNN. We extend the Mask RCN to include an additional multi-label attribute prediction head, which is trained with sigmoid cross entropy loss. Attribute Mask RCN can be trained end-to-end for jointly performing instance segmentation and localized attributes recognition. Our main evaluation metric reports average precision score across all the categories and all 10 IOU threshold and all 10 macro F1 scores for the predicted attributes of the detected instance. As shown in the table, our baseline models achieve promising performance on this challenging task. We also notice a significant drop in the AP score if we add the F1 score as an additional constraint for the true positives. This suggests that the proposed task is a significantly more difficult task than instance segmentation, leaving much more room for further improvement. We also compared two detectors trained on Fashionpedia and Coco dataset. Errors of the Coco detector are dominated by imperfect localization and background confusion. Meanwhile, no mistake in particular dominates the errors produced by Fashionpedia detector. Check out our paper for more details about evaluation protocol, baseline results, and discussions, especially for the category level results. To conclude, in this work, we focus on a new task that unifies instance segmentation and attributes recognition. As an example to illustrate this task, we introduce the Fashionpedia ontology and dataset. To the best of our knowledge, Fashionpedia is the first dataset that combines part-level segmentation masks with fine-grained attributes. We presented Attribute Mask RCN, a novel model for this task, along with a novel evaluation metric. We expect models trained on Fashionpedia can be applied to many applications, including better product recommendation in online shopping, enhanced visual search results, and resolving ambiguous fashion-related words for text queries. We hope that Fashionpedia will contribute to the advances in the fine-grained image understanding in fashion domain and beyond. We thank all the collaborators for making this project happen. Please also check out our project website for more information and updates in the future. Thank you.